Okay, so Baby Pandas also provides some of the same methods that NumPy arrays have, because series are basically arrays. So for instance, what was the biggest or smallest salary? Who was paid the most? Right? What was the average salary? We can answer these questions with some of these series methods. So, for instance, let's find the smallest salary. Who was paid the least, unfortunately? We'll get the salary column like this. Okay, so we have all of our salaries here. Remember, this is basically an array, so I can do dot and min. And it'll tell me the smallest salary was just $0.03 million. Okay, if I want the biggest salary, I do dot max, it was $27 million. And this is back in 2015. The salaries have really increased since then. And then the average salary, I could ask dot mean, is $5.5 million. Okay. Now I want to ask not what the biggest salary was. I want to ask who had the largest salary. What player? What was their name? So one of the ways I can answer this is I can sort the table by salary and then just take the name of the player who appears in the first row. So this is a general strategy that you can use to answer questions like who had the biggest salary, who had the smallest salary, and so forth. We sort and then take the first or the last row. So how do we sort? There's a sort values method. So we take our table, write dot sort values, and then we say by equals the name of the column we want to sort by, right? Because with a column with a table like this, I could sort by a ton of different things. I could sort by their 2015 salary, their adjusted salary. I could even sort by their position that they play. So in this case, we want to sort by their adjusted salary. So I write sort values by equals adjusted salary. And I do that, and I get a table that's sorted by adjusted salary. You'll notice that it's sorted from smallest to largest. Okay, so unfortunately, Thanasis Antetokounmpo made the least amount of money in 2015, but we see that Kobe made $27.25 million in 2015. Okay, so first thing to note is whenever we sort, we go from smallest to largest by default. Here I'm writing another keyword argument, by equals adjusted salary. I can't call this whatever I want. I have to call this by, or else Python won't understand. In fact, I don't even have to put this at all. I could leave it out and it'll work just fine. But I think it kind of looks nicer, it reads easier if I write sort values by adjusted salary. Okay. Now, keep in mind, this creates an entirely new table. If I ask for the old table back, if I ask for the value of adjusted salaries, it's not sorted anymore. Okay. If I wanted to save this, I would have to assign it to a new variable. Okay, everything worked here, but maybe I wanted to sort in descending order instead of in ascending order. I can do that by just calling sort values in a slightly different way. I use a keyword argument called ascending equals false. So if I just add that here, ascending equals false, now I see that the table's flipped. I've sorted from largest to smallest, and Kobe Bryant is at the top. If I go back and I change ascending equals false to ascending equals true, I get the default behavior from smallest to largest. Okay, so let's change this back to, okay, so it's sorted from largest to smallest. And now I just want to get the name of the player who made the most money. I can see now that it's Kobe Bryant. So in essence, I've answered my question. But if I wanted to do this with code automatically, so I didn't have to have a human come and take a look at this, how do we get this player name? Well, remember, that's in the index. The player names are stored in the index. I want to get the entry in the index that's at the top, the first row. So I do dot index square bracket 0, and I get Kobe Bryant. So let's put some of these tools together. think about this question. What team did the person with the third lowest salary play for? So what team did the person with the third lowest salary play for? So we have all of the tools. You can pause right now and kind of think, how would you do it? In fact, if you're following along in the notebook, as I suggest with all these lectures, try to write a little bit of code, try to answer the question. Okay, but we'll go ahead and see. What team did the person with the third lowest salary play for? So there are a few strategies. Here's one. First, I sort the table by the values by adjusted salary. I get the name of the person using .index2, because remember, sorting by default goes smallest to largest. So to get the third person, I go 0, 1, 2. So I go .index2, and that gives me their name. And then I want their team. So then I do .get team. I get the team column, and then I ask for the team of this person. So I do .loc and then their name. So let's try it out. So I sort the salaries. Okay, so I get the lowest salaries first. Then I want to get the name of the person with the third lowest salary. So that's Jordan McRae. I would do that with .index2. Okay, so name equals lowest salaries .index2. Now I need to get their team name. So I'm going to do that with, remember now Jordan McRae is stored in name. I say get the team corresponding to this player. And it says Phoenix Suns. Okay, so that's the first strategy, but here's another strategy. So I first had to find the player's label, right, in order to get their team, right? And it seems kind of roundabout here. Like, all I wanted was the team name of that third row. Can I just say, give me the team name of the third row? I don't care about what its label is. I don't want to find that out. And yeah, we can. And we're going to use .iloc to do that. So we've learned loc, which says you have a column, give me an entry corresponding to this label. iloc says you have a column, give me an entry by number. So 0 being the first, 1 being the second, 2 being the third, and so forth. So using iloc will save us a little bit of work here. We get the team column. Okay, we've already sorted here. Okay, so that's step 1. We just left that off on the previous slide. We've sorted by salaries, smallest to largest. We get the team column. We could .loc Jordan McRae. We would get Phoenix Suns. Or we could .iloc2 and get the same information. So what we're doing here, right, we could look up this piece of information by saying, give me this column and give me the entry corresponding to Jordan McRae, or we could say, give me this column and then the third entry in the column. Okay, so we look up, iloc stands for integer location. LOC is just location, label-based location. iloc is integer location or index location. Okay, so this is all of that put together. We sort the table, sort values, get the team column, and then iloc2, Phoenix Suns. Now, something I want to point out here is that we've written all of this code on a single line. It's not always good to write all of your code on a single line, and a lot of people try for it. They're like, I want to write all of my code as concise as possible, and that's not always a great strategy because it makes it hard to read. But in this case, it's not too bad. What this is called is method chaining. What I've written here is a method, sort values, and remember the result of this whole call right here, if I can highlight it, the result of executing that code is itself a table. It returns a table. And so then I can take that table and .get team. And so the result of this would be a series. And then I can do .iloc on the series. So it's helpful or it's useful to write code like this, to chain the methods. And we'll see this pretty frequently in the rest of the quarter. Okay, so here's a summary. You want to access a particular element in a column of a table. You can use .loc to access using the row label, the player name, or iloc to use the integer position. Usually .loc is more convenient, but sometimes iloc is more convenient. It depends on the particular question. You should know how to use both. Okay, just a note, sometimes the row label is an integer position. So that's actually what happens by default. If I just read in the NBA player salaries, remember, it doesn't set the index by default. I have to do that. If I don't set an index, remember the row labels are just 0, 1, 2, 3, 4. Those are the positions, the integer positions. So then I could say, okay, well, what's the third player in the data set? That's Jeff Teague. But I could also ask iloc, what's the third player? That's Jeff Teague. Whether I'm using loc or iloc here, it doesn't matter because the row labels are integers. Okay, we've learned a lot about tables, but there's still a lot left to learn. So for instance, I want to ask questions like, what is the total payroll of the Cleveland Cavs? How many players make over $10 million? Or who is the highest paid center? These are more complex questions. We don't quite know how to answer them yet, but we'll see that in the next couple of lectures. And as we'll see, it won't take much code at all. So some analyses like we've done today, we could do those in Excel just as easily. But asking things like, what is the total payroll of the Cleveland Cavs might be a little bit harder to do in Excel. And it's the sort of thing that Python really excels at.